Okay, so the modulus and argument of z, we first need to find the modulus, so it's simply the real part squared plus the imaginary part squared, square rooted, so that's the square root of 64 times 3 times plus 3 times 4 times 64, so that must be 16. And the argument is the inverse tangent of the imaginary part divided by the real part, which gives an argument of, sorry, I need a negative there, an argument of 2/3 pi. Now, so we've got so we've got 16 2/3 pi. I'm going to draw that. So there's 16, there's 2 pi by 3. Now I'm going to find z cubed. Now when we cube a complex number in modulus argument form, we simply cube the modulus to get 16 cubed, which is 4096, times, now we need to multiply the argument by 3, which gives 2 pi. Cosine 2 pi is 1, I sine 2 pi is 0, so it's just 1, so the answer is 4096. Part C, find the values of w such that w to the power 4 equals z. So basically we find the fourth root of this. We're going to get 4 answers. When you take the fourth root of a complex number, you take the fourth root of the real part, so modulus, sorry, fourth root of the modulus, so we're going to get 2 times the argument divided by 4. So we're going to get cosine pi by 6 plus I sine pi by 6 as one of the answers, and the other ones come from what other angles do you multiply by 4 to get 2 pi by 3? Well, 2 pi by 3 could also be 8 pi by 3. That's just 2 pi more. And 8 pi by 3 divided by what we're dividing by 4 gives 2 pi by 3. Another one would be, now we want these in real and imaginary form, so this would be 2 at an angle of, well, the real part is 2, real part here is 2 cosine pi by 6, cosine pi by 6 is root 3 over 2, so that's root 3, plus 2 times half is 1, so root 3 plus 1 is that. This one here, cosine of 2 pi by 3, you could just whack this into a calculator, but I'll struggle along, is minus 1 plus root 3. And the two other solutions, again, I think it's much easier to use the fact that this is also, add another 6 pi by 3 onto that, 14 pi by 3, divide that by 4 and whack it into this form. We get that that equals minus root 3 minus I, and the other one is, I don't know why I'm writing equals here, so whatever would go there is equal to 1 minus root 3 times I. So those are the 4 solutions.